Hello, this is Mr. Craig, and I'm going to go right to the examples as the lecture for today. The first thing that we want to talk about is atomic masses, and you'll notice on your example sheet that is the thing that is addressed there, the first thing. So let's talk about atomic masses. Well, with atomic masses, we have to realize that when we look at a periodic table, and if you look at your periodic table, you'll notice that the majority of the elements, actually all of the elements, there's a few over here, have a decimal value. They don't end with 0.00. Now, oxygen, fluorine does. Carbon on a lot of periodic tables ends at 0.00. But for the most part, when we look at a lot of these elements, they have like 0.94, 0.93. They've got some really random type of decimal places. And you may have asked yourself, why in the world do those not have whole numbers? Well, back in General Chem when we talked about isotopes, these are elements that have different numbers of neutrons, so that means that their atomic masses are different. And the values that we find on the periodic table, or that we care about on the periodic table, are the average of all the isotopes. So you may be asked to calculate or determine, if you say later on in life and you find or create a new element, you may be asked to find out what its molar mass is. Or for a more practical application, I actually made a bonus question on this that you don't have, and I more than invite you to try the problem out once we get to it, is to find out what your grade is for a class, because now that, especially here at Avon, where we have weighted classes, not every point is equal. Okay, so in other words, test points have more value than a quiz point, or the quiz points have more value than a homework point, and so on and so forth. So when we look at stuff like that, even though you might say, oh, I'll never use this, well, figuring out percentages for values or for things that have different masses or different weights will be very important. All right, so let's get to this. It says element X consists of 33.1% of an isotope with a mass of 22 AMUs. Now, what is an AMU? An AMU is an atomic mass unit, or the mass of one proton, or, if you want to argue, the mass of one neutron, which is fine. They have a very, very small mass, but that's why we clean it up and say 1 AMU. All right, and then 8.6% of an isotope with a mass of 24 AMUs, 20.7% of an isotope with a mass of 25 AMUs, 16.5% of an isotope with a mass of 27 AMUs, 21.1% of an isotope with a mass of 30 AMUs. Calculate the average atomic mass. All right, so probably the best way to do this, and I don't know if you all did this in General Chem, and if you didn't, that's fine. I think I had my students do this in General Chem. But there's a couple ways you can do this. Now, there's always more than one way to solve a problem, and I want you all to be good problem solvers. However, what I do is I try to move the decimal place. In other words, I'll move the decimal place over 2 places so that it makes my calculations just a little, on my percentages. So on my percentages, I'm going to move the decimal places over 2 places. And you'll notice on the point, or the 8.6%, I have to move over 2 places and I don't want to leave it as 0.8, because that would give us an 80%. So I'm going to move all the decimal places over and then find out what these values are, add them up. That'll give me my average. It's pretty cool. So 33.1% is 0.331, and it's no longer a percent. And I'm going to multiply that by my atomic mass, so 22 AMUs. Now you'll notice that these are all whole numbers, because you can't have a part of a proton or part of a neutron. It just doesn't exist. And we'll find out what that value is here in a moment. So the point, we'll have 0.086. Now again, we moved it over 2 places, because if we only moved the decimal over 1 time, that'd be 86%. That's not what we're looking for. So a very small percent of this has a molar mass of 24 AMU. Okay, and then we have 20.7% of 25 AMU, and then we have 16% of 27 AMU. And then we have 0.21% of 30 AMU. Okay, so here's what I'm going to do. I'm going to first of all figure out what all these values are, first of all. So I'm going to get my calculator out, and hopefully you're doing this as well. So I'm just taking these values and multiplying them out and getting some numbers here. Oh, come on back here, calculator. So I'm going to go 0.331 times 22. And that gives me 7.282. 0.282. And then I've got 0.086 times 24, which is 2.064. 2.064. And then I've got, wherever my mouse is, 20% or 0.207 times 25 AMU, and that's 5.175. 175. And then I have 16.5% times 27 AMU. So 4.455. So 4.455. Okay. And then the last one here, 21.1% times 30. So 6.33. All right. Now that we have all these values, just add them up. And the really neat thing about this is, if you did it right, once you add all these up, this answer, whatever this number is, will be somewhere between 22 and 30. Hence, average. Okay, so let's go ahead and calculate these out. So 7.282 plus 2.064 plus 5.175 plus 4.455 plus 6.33. And we get a final answer of 25.306. And since this is an average, we don't want to round that. So 306, I think it said. Yeah, 306. And again, thinking about this, yeah, it should be somewhere between my high and my low. So if you got a value, say, of 125.306, then you may want to double check your math, because you may not have done something correctly. Like, probably what I would speculate is you may have had 86% instead of 8% on that 24 AMU. All right, next question. Here's the bonus question, or an additional question here, and this is more of a real application type thing. You don't have this on your example sheet, so if you want to pause the video and try this out on paper, because I think the examples that I gave you only had questions on one side, so flip that sheet over and work this question out on the back. All right, so 1B, or the bonus question. Your final grade for a certain class is determined by the following percentages. Tests make up 45% of your total grade. Quizzes make up 25% of your total grade. Projects make up 13% of your total grade. And the semester final exam makes up 17% of your total grade. Determine your final percentage for this class if you receive the following percentages for the class. So your test, you got 83.86%. Now, if you got 100% on all of these, it's a no-brainer. However, we have to find out what our actual percent is. So, since the tests make up 45%, I'm going to take 0.45%. Okay, that's what makes up my total. And I'm actually going to multiply it times 83.6%. Now, I'm going to leave that percent on there because this is a unit. That's different than this. Okay, so 45% of my total grade comes from tests. Well, how much did I earn? Well, I earned 83.6. Okay, so let me erase that real quickly. All right, go back to that. Okay, so we'll figure out what that is. Then we have 25%. So I'm going to move the decimal over 2 places. So 0.25 of my thing is quizzes, and I got 91.4% on my quizzes. And then 13% of my total grade is from projects. So that's 0.13 times 98.7%. Okay, and then we have 17%. Oh boy, I think that adds up to 100%. 73%. Okay, so let's see here. Yeah, that adds up to 100%. All right, so getting the calculator out and doing this again. Okay, so we're going to take 0.45, and this is how you can find out your weighted grade. So you don't ever have to go up to your teacher. If you have your percentages in front of you, then you can always do this type of calculation at home. So 83.6, and you'll notice once I take the 0.45 times 83.6, that changes it. So 37.62. Oops, 37.62%. Now that doesn't mean you have a 37.62%. Unless you got zeros on the other projects, or I'm sorry, on the project, quizzes, and final exam. So, all right, and then 0.25 times 91.4, so 22.85, 2.85%, and then 13%. So 0.13 times 98.7. So 12 point. So you'll notice that even though this score, 98.7, it really only contributes about 13% if you got a 100 on there. 13% of your total grade. And that makes sense. So 12.831. 12.831. And this is what the computer does for us. As teachers, it automatically does that calculation for us, and that's kind of nice. I mean, there's a lot of people that cannot do these types of calculations, and that's why I want to teach you how to do this. And then 0.17 times 73, so 12.41. All right, so now that we have all of our values, add them up. Okay. So we already have 12.41, so I'll leave that in there, plus 12.831, plus 22.85, plus 37.62. So the final grade would be an 85.7%. Okay, that's not bad. 85.7%. Okay, and again, one real quick way to make sure that this makes sense is that this answer right here should be somewhere between your high value and your low value. And that just stands to reason that if you had, say, zeros on all of these, on these other three, but you got 83.6%, then your value should be somewhere between here and 0. So that's a real nice application for you to be able to determine your grades if you know the percentages. Hopefully you're given some sheet at the beginning of the year giving you the point, I'm sorry, not the point breakdown, but the percentage breakdown. If not, ask your teacher. All right, let's look at question number 2. It says calculate the molar mass for 10,4-phosphate. All right, well, the first thing that you have to do on something like this is write the chemical formula. So what's the symbol for 10? That's right, it's SN. And what's the charge on this 10? This 10 has multiple charges. I know of at least 2 charges that it has. In this case, 10 has what charge? That's right, the 4 here. So that means that Roman numeral always signifies the charge on the metal. And it signifies the charge on each metal atom. All right, and then phosphate, well, since it ends in ATE, that means you have a polyatomic ion. So phosphate is PO4. Oops, let's go back. Sorry about that. And what's the charge on phosphate? That's right, one of our 10 polyatomics, so it has a -3 charge. So we want to make sure, again, as what we were learning earlier on, I think on the first or second day, let's make sure that the algebraic sum equals 0 since we have an ionic compound here. You know you have an ionic compound because you have a metal with a nonmetal. How do you know you have a metal? It has a positive charge. How do you know you have a nonmetal? You have a negative charge. All right, so we want to balance these charges out so the algebraic sum equals 0. So we only use parentheses on polys. So I'm going to put 3 here. It should be a 3 and a 4 there. Ooh. And so we'll multiply that by 4, multiply that by 3. So plus 12 minus 12 gives us a 0. Okay, so we have our formula written out correctly. Now to determine the molar mass, well, we have 3 10 atoms, and I don't have that memorized, and neither should you. So we need to look on our periodic table and find 10, which is right here, element number 50, and it has a molar mass of 118.71. Okay, so 118, oops, sorry, 0.71, and that's grams per mole. Again, molar mass, grams per mole. And then we're going to add that to the total number of phosphorus atoms. So how many phosphorus atoms do we have in this compound? Well, we have 1 within the phosphate, but we have 4 phosphates. So that means that we actually have 4 phosphorus. And the molar mass for that is right up here. Phosphorus element number 15 is 30.97. So we'll multiply that, 30.97. And again, that's grams per mole. Okay, and then we're going to look at the last element, which is oxygen. So how many oxygens do we have? Well, we have 4 oxygens in our phosphate, but we have 4 phosphates. So we have 16 oxygens. Oops, nice parenthesis. Go up, parenthesis. Okay, so again, looking at the periodic table, oxygen's over here. So it has a molar mass of 16 grams per mole. So we'll put that 16 grams per mole. Okay. And let's do some calculating. Hopefully my calculator will be able to do all this for me. Actually, let me scoot it down just a hair so you can see everything. Alright, so we've got, let's clear that up. And I know some calculators are better than others, so I'm going to go scientific so I can have some parentheses on here. And I wouldn't, your calculator should be able to calculate this in the order of operation. This calculator, the one that Microsoft Windows provides, is garbage. I hate to say it, but it is. It's terrible. So I'm going to use parentheses to help safeguard because this calculator does not understand order of operation. It understands you type a number in, it calculates it, and that's not order of operation. So 3 times 118.71, close the parentheses, plus, open up another set of parentheses, 4 times 30.97, close the parentheses, and again, I would not recommend you doing this. You don't have to on a calculator. It'll automatically do this for you based on its order of operation. And then 16 times 16. And then close that baby up. And we get a molar mass of 736.01. And since we're looking for molar mass, oops, let me scoot that down. Since we are looking for molar mass, do not round. What was that? 736. Okay. 736.01. Oops. And again, grams per mole. Okay. And I think you all remember how to do that, even in general chem. The hardest part of this whole question is balancing out that equation. So once you get this balanced out, it better be a piece of cake. Okay. All right. And if you need more practice on this, I go back to day 3 or 4. I think it was day 4 on balancing equations. And I've got a lot of practice work on there for you if you need work on balancing the equations. All right, number 3. Calculate the number of milligrams for 550 atoms of zinc. All right, here's one thing that we need to know. We need to know the progression from higher to lower. In this case, we are given milligrams. Okay, so I'm going to give you a little chart here going from milligrams. If you're given milligrams, and we're looking for atoms in this case, is there a conversion for me to go from milligrams straight to atoms? Well, if you know of one, let me know. But no, there isn't one. So what I need to do is I need to convert the milligrams into a unit that I can use to help determine the number of moles. So I always want to go to moles. If I'm ever given mass, about 97% of the time, we want to go to moles. If you're given mass, which is in grams, milligrams, kilograms, whatever, you want to go to moles. So we need to figure out a way that we can get to moles. Well, the only tool that I know of is the periodic table. And again, the molar masses for the individual atoms are right here. So zinc has a molar mass of 65.39 grams per mole. So since that's in grams, then we want to convert the milligrams into grams. Okay? We have to do that. We have to convert the milligrams to grams. And then once we have the number of grams, now we can convert that to moles. And what's really nice, once you have it in moles, now we can do a lot of things with this. So in this case here, it wants to go to atoms. Well, if we had a compound, we would go from moles to molecules and then atoms. But in this case, we can go straight to atoms since we don't have a molecule. Okay, so if you were given a molecule, say like zinc oxide, okay, for example, okay, we weren't, but you would go to molecules. And if you're not given a molecule, don't get creative and try to make up something like that. And then atoms. Okay, well, in this case, we don't have any molecules, so we just go from moles right to atoms. Okay? So here's how we do that. We always start off with what's given. Okay? We always start off with what's given. So in this case, actually, let me clean up some of this here. Erase that. Get rid of the arrow. Okay, so we always start off with what's given. So we start off with our 550 atoms. Okay? Now, a lot of people have told me that this is probably one easy way to do it. Write in the units before you write in the numbers. And I like that. I really, really like that. And it's kind of nice because then you don't get hung up on, well, how much is in that? And if you write the units, it's going to keep you out of trouble. All right. And we must write and use units. We must. So if it's not the unit that you're looking for, in this case here, does the question want to know how many atoms? No, it wants to know how many milligrams. So if it's not the unit you're looking for, you need to slide it diagonally. Now notice I didn't say down. Slide it diagonally, because if you had a unit here, to get rid of it, we're going to need to slide it diagonally in that direction. But we don't have a unit right there. Okay. So, but if we did, we would. So we're going to take atoms, and we're going to write atoms right down there. Okay? And then we go from atoms, we said to jump over molecules, so we'll go right to moles. Okay, let's not write the units in yet, or the numbers in yet. Okay? Do we want to stop at moles? No. And remember, the unit that we're looking for must be on top. It has to be in the numerator. It cannot be in the denominator, or you have the inverse of the answer, which is normally not a good thing. All right, so since we're trying to get to milligrams, let's move moles. Okay, we're going to take it from here, and we're going to slide it diagonally. And we're going to convert the moles into grams. And I want you to notice something here. These values up here are on the top. So we're going from moles to grams, so grams should be on top. Then we're going to convert those grams into milligrams. And we have our unit that we're looking for here. All right, so let's go back. Let's ask ourselves, whichever of these two units is largest always gets a value of 1. So which is bigger, 1 mole or 1 atom? Well, I have Avogadro's number of atoms, which is 6.02 times 10 to the 23rd atoms in 1 mole. Okay, so a mole is so much bigger than an atom. In other words, I have a lot of atoms compared to 1 mole. Okay, because 1 mole of a substance is much greater than 1 atom of that substance. Okay, all right. Now I'm talking. Don't worry about it. All right. Now when we come back over here, when we look at mole within the problem, about 95-6% of the time, whenever you see mole within the problem, we're going to give it a 1. Okay. The reason being is because now we have to come back to the periodic table, and if I had 1 mole of zinc, how many grams is that? 65.39. Okay, so we're going to write down 65.39. So whenever we have moles over grams or grams over moles, that mass value always comes from the periodic table. Okay, you always have your periodic table out. All right. Then our last step, I have to ask you which is bigger, milligram or gram, and I think we did this earlier on. And yes, gram is much, much bigger than a milligram. How many milligrams are there in a gram? That's right, 1,000. Okay, so we have 1,000 milligrams in a gram. All right, well, I hope this calculator can handle this. All right, so looking at this, let's clear this. Actually, let's scoot that down just a little. Okay. Hopefully I can get it. All right, I think it'll work out here. All right. Do I have an exponent? But yeah, I do. All right, so let's clear this out. Clear. All right, so 550 atoms. 550 atoms times 65.39 grams times what is 10 to the third? That's right, 1,000. Okay, now since I have to divide it by Avogadro's number, I want to hit equal and then divide, and I'm going to use parentheses on this because I don't trust this this calculator very well. So 6.02 to the power, oh my gosh, ugh, cannot stand this calculator. Sorry guys. Shoot. I hate this calculator. Oh dang it. All right. I think let's do 6.02 times this. Daggone it. Are you kidding me? Times, is there a caret on this thing? Oh, I hate this calculator. Sorry, I shouldn't say. Oh, wait a minute, what's that? Oh, here we go. Let's try that. 23. Probably gonna not like me on that. It did not. Alright. 6.02. 0.02. 0.02 exponent 23. I'm kind of liking this now. Equals negative. That I like. All right, so we have. Whew, that was painful. All right, so 5.97 times 10. 5.97 times 10 to the negative 17 milligrams. Wow. Oh, I don't like Microsoft calculators. Okay, so 5.97 times 10 negatives. Yep, okay. Whew, that was ugly. Sorry about that, guys. Hopefully you had no problem with your calculator on typing that in. If you did, here's how you would type it in on your calculator. It'd be 550 times 65.39 times 1. And I love using the EE button if you have a Texas Instrument calculator, or EXP button if you have a Casio. And what these two buttons are, they're times 10 to whatever number you type in next. So that is the EXP and EE are times 10 to the n power. So if you type in 20, or I'm sorry, in this case 3, that should be 1 EE3, should be 1,000. And then you can type divided, parentheses, 6.02 EE or EXP, whatever calculator you have. Do not get a graphing calculator. 23, and then equal. And it should give you that. Okay? All right. Knowing how to use your calculator is just as important as knowing how to set these problems up. It is your calculator. Don't buy a fancy graphing calculator. Do not buy a fancy calculator. But do make the calculator look a little more than this. I mean, we don't want a standard calculator. That's not going to serve you any good in this class. So, a good scientific calculator, not a graphing calculator. You will not be able to use a graphing calculator on any of the tests or quizzes in this class. All right, number 4. Is this the last one? It looks like it is. All right. Calculate the number of oxygen atoms in 75.3 kilogram sample of lithium sulfate. All right, so again, let's take the hard part out. Let's write the problem out, or the formula. So lithium, Li, and it has a charge of +1. Sulfate, SO4, and it has a charge of -2. So that means I need 2 lithiums. No parentheses. Remember, parentheses are only for polys. All right. The question here, it's kind of a dirty one. It wants you to know how many oxygen atoms. So in this molecule, how many oxygen atoms are there in this molecule? That's right. In this one molecule, there are 4 oxygen atoms. Okay? So we'll come back to that. All right. So let's start off with what we know. We have 75.3 kilograms. Okay. And so what do we want to do? Well, remember our little stepwise thing up here? Instead of milligram, we're going to start off with kilogram. So we'll still convert the kilograms to grams. So kilogram, we're going to put kilogram down below, gram here. Okay, and don't worry about the values yet. We'll come back. And then we're going to convert the grams. I'm going to slide it first of all into moles. And then we're going to convert the moles into molecules. And we didn't have a chance to do that last time because we went straight to atoms. So in this case here, we do want to go from moles to molecules before we go from molecules to atoms. So we will use all those steps there. Okay? And then the last step, since molecule to atoms. And again, to be more specific, oxygen atoms. Okay. All right, so let's go ahead and put our values in here. Which is bigger, kilogram or gram? That's right, kilogram. Kilogram is much, much bigger than a gram. How many grams are there in a kilogram? 1,000. Very good. All right, we have our mole again, so we're going to go ahead and put ones where the moles are. Trust me, it's going to save you a lot of effort. Put oxygen there. How many moles? Ooh, we still have to figure that one out. So let's figure out what the molar mass of that is. So 2 lithiums, 6.94. So 2 times 6.94 equals plus, I'm going to use parentheses here. How many sulfates or sulfurs do we have? We have 1 sulfur. So sulfur is 32.06. 32.06. Okay. Plus, how many oxygens do we have in this compound? We have 4. And again, oxygen 16 grams per mole. So plus, let's use parentheses, 4 times 16. And that gives us a molar mass of 109.94. 109.94. So 109.94. All right. So that's our molar mass for lithium sulfate. How many molecules are there in 1 mole? You know what? It's kind of crazy. The same number of atoms in 1 mole are the same number of molecules in 1 mole. So remember that Avogadro's number is just a number. However, the unit that you put on there is pretty darn important. Okay? So if I had 1 mole of pennies, then I'm going to have 6.02 times 10 to the 23 pennies. Now, if I wanted to find out how many atoms of copper I have in that penny, well, I need to find out how many pennies I have and then find out how many atoms in 1 penny I have. So, a little bit different there. All right, and then in one molecule, since a molecule is much, much bigger than an atom, in one molecule of lithium sulfate, how many oxygen atoms are there? That's right, there are 4. Boy, that looks bad. Oxygen atoms. Okay, I don't want that to look like a 40. All right, so let's calculate and see what that's equal to. Kind of scoot that down a little bit. See if my calculator will cooperate now that I know how to use it. All right, so let's multiply everything on the top first. So 75.3 times 1,000 times, I'm going to use parentheses, 6.02 exponent 23, close that parentheses, times 4. So that give me a value there on top. All that is on top. Then I'm going to divide that by 109.94. And that equals, wonderful. I love my scientific notation here. So it's 1.64. Good night. I love this. So 1.64 times 10 to the oh brother. 1, 2, 3. Seven to the positive 27. Okay, and that again is atoms of oxygen. All right, I hope that this was all review for you guys. My goal was that you didn't learn a thing from this lecture. If you have any questions, don't hesitate. Email me.